translates into Italian in an interesting way. Of course, John is Giovanni, or for short, Johnny, and lamb can be translated into Agnello or Agnelli. So you can call me Johnny Agnelli anytime you want. I have the name, but unfortunately, I don't have the money. You've probably had a chance to look over the course outline, and you realize that we're going to be talking about a number of interesting topics over the next 14 weeks. And I hope to be able to bring these topics to life and that we can work together to gain a better understanding of a lot of things that relate to science and theology together. Most of all, I hope we can enjoy our time together and that we'll come away having learned something worthwhile. Of course, the course is being given in English. If it were being given in Italian, you probably wouldn't understand it any better. Given my expertise with Italian, my level of expertise. Along the way, we're going to be talking about some scientific topics, but I will try to keep technical terms to a minimum and keep them to the kind of terms that you've probably heard before in school. People are often afraid that a course like this might include a lot of mathematics. There won't be much, if anything, in terms of mathematics, and what I will present to you will be very basic. So don't be too worried. As Brother Pergo mentioned, I hope that we can encourage you to make note of your questions so that we can address your questions in an appropriate way. If possible, hold them to the end of the lecture, because as a matter of fact, the answer may already be in the lecture, we just haven't got there yet. This course will require that you have access to some reading materials, including these 4 books: The Lectures on Faith, The Key to the Science of Theology, Joseph Smith as Scientist, and Teachings of the Prophet Joseph Smith. And along the way, as we talk about these individual texts, we'll have a chance to get to know some of these people who wrote them. I'm assuming everyone has access to the scriptures of the church, and we'll be referring to them a lot. I'm going to try to post most of, if not all of, the readings, which are excerpts from these texts, so that you have ready access to them. And I'm not going to quote a lot of sophisticated science, so I won't be taking quotes from science textbooks. Don't be afraid that there's going to be so much science in this course that it will scare you. If there are science-related texts, I will, again, post them as readings for you. Just so you can get to know me a little bit, I spent my career at BYU both teaching and doing research. This is the kind of molecule that we studied. It has a cavity at the center so that other molecules can be trapped in that cavity. We did chemical separations in my research lab. I was at BYU from 1978 to 2016. And over the course of the years, I was able to visit other countries, especially Italy. Having been here on my mission in 1973, I took every chance I could get to come back. And I had the privilege of serving as a visiting professor at 3 different universities on several occasions: the University of Catania, the University of Parma, and the University of Pavia. I have a picture here of one of my good friends, colleague at the University of Catania. His name is Pino Arena. If any of you are from Catania or went to that university, you took a class from Pino. My wife, Betty, and I are currently serving as Rome Temple Visitor Center missionaries, and it's a wonderful time that we're having at the Visitor Center. We have 6 boys, these are they, And among them, 3 are married, 3 are not. And we have 11 grandkids pictured here. We just love them to death. Well, let's get into talking about our course. Our course obviously is about science and religion. And it's commonly thought that science and religion are often at odds with one another, enemies, so to speak. And the hope that I have is that perhaps we can find some opportunities over the next weeks together to find ways that science and religion actually go well together. In fact, I've set out some objectives for our course, which I'd like to share with you. At the end, you should emerge with a greater appreciation of the complementary nature of natural science and theology in revealing the truth about God's creations. Also, a greater understanding of the degree to which latter-day theology, as revealed through Joseph Smith, is compatible with 21st century science. And finally, I hope that you'll gain an increased faith that apparent conflicts between science and religion can and will be resolved. So we're going to be talking about an awful lot of interesting topics, which I hope will appeal to at least some of you all the time, or all of you some of the time. They include things like the Big Bang, medieval cosmology, dark matter, kingdoms of glory, four-dimensional space-time, light and the Holy Ghost, electromagnetism, God in the gaps, supermassive black holes, voodoo science, and we'll even introduce some interesting characters like Einstein, Brigham Young, and Aristotle. As we go through the next few weeks together, we're going to mention the church many, many times. So if I do use the term the church, I hope that you'll recognize I mean the Church of Jesus Christ of Latter-day Saints. So with that introduction, let's begin with lecture number 1, which I have named Joseph Smith and the World We Thought We Knew. First, let's get familiar, a little more familiar with Joseph Smith. I'm sure you know who Joseph Smith was, but I think that you can recognize, I hope you'll recognize, that our course objectives are going to be best achieved through historical context. Having an understanding of when Joseph received revelations and what Joseph did on various occasions will really bring to life the kinds of teachings that he taught, when he taught them, how he taught them, to whom he taught them, under what circumstances. I think that makes history a lot more interesting. And in order for us to gain an understanding of the revolutionary nature of Joseph's teachings and how they relate to science, we're going to need to have that context. So I invite you to immerse yourself in Joseph Smith's history. And as you do that, it will help us compare how science viewed the world and how religion viewed the world, both before Joseph Smith and after. And in doing so, we'll see how many of the conflicts between science and religion were actually resolved through Joseph Smith's ministry. So Joseph Smith Jr., who was he? Well, his contemporaries didn't call him Joseph Smith so much. They like to call him Brother Joseph. And there's a bit of a lesson from that. Joseph took himself seriously in many ways, but also was not particularly standoffish as a prophet. He was a common person. He loved to be with other people. He never took on airs of being superior. And that's why people loved him in part, because they called him Brother Joseph. That's the way he felt about himself. That's the way they felt about him. What's amazing about him is that over the course of just a few years, he laid the strong doctrinal foundation of the church, which has lasted to this day and upon which subsequent prophecies and revelations have been built. When you think about all the things he was able to achieve, it's really astonishing. During the course of those years, he brought forth the entire Book of Mormon with all of its interesting and important teachings. Also, the Pearl of Great Price, all 4 parts of it. Also, the Doctrine and Covenants, and 135 of the 138 sections are directly from him. He also did a translation of both the Old and the New Testaments. It was a translation in quotes because he didn't sit down with the original texts and retranslate them. Rather, through his prophetic seership, he was able to fill in some gaps and correct some mistakes that had accumulated over the years. Another amazing accomplishment was the development of temple ordinances and the instructions that we receive in the temple. And beyond that, there are various writings and sermons that were recorded of things that Joseph taught. Many of these are collected in the book that we referred to earlier, The Teachings of the Prophet Joseph Smith. But also, there is an ongoing project at BYU to collect together pretty much everything that Joseph said in his lifetime and wrote, called the Joseph Smith Papers. It's taking scholars years of work to collect and organize all this stuff, and it just is another testimony of how prolific Joseph was as a prophet. Think of it, in just 24 years, he did all those things. And you can imagine it would be hard for any one of us to come up with one of those things, let alone all of them in that much time. So if we want to take a moment, it will help us plant in our minds some historic pins. What I mean by that is names, places, and faces that we can connect with Joseph, his life, and his revelations. And this will help bring the story alive. So let's review a little bit about his life. There are a few dates that every LDS person who is seriously interested in LDS history and in the history of Joseph Smith should remember. There are probably more, but at least these few give us some milestones in Joseph's life to help us recall. He was born, maybe you know. You remember? 1805. He had his first vision, maybe you remember, in 1820. The church was organized in 1830. The Kirtland Temple is another milestone because it was there that Elijah came back to restore the keys of the turning the hearts of the children to the fathers and so on. And that was, of course, in 1836. Then we have the Nauvoo period, a very important period, which began in 1839 and ended in Joseph's martyrdom in 1844. So I would suggest that you make a note of those dates and memorize them. It will help you not just in this course, but throughout your life as you study the scriptures and the teachings of the prophets that you can kind of imagine and remember what the context of those revelations was. Also, places. Places are interesting. Joseph, of course, was born up here in Vermont, but as far as church history goes, Palmyra is probably the most important first place. That's where the first vision occurred, and where, in that area at least, where the church was organized. It was a short time after the church was organized, though, that it moved to another place further west and a little bit south, Kirtland, Ohio. There the church remained from 1831 to 1838. And during this period, Joseph received many of the very important revelations we find in the Doctrine and Covenants, including the ones that we'll be talking about today and next week. And then finally, from 1839 to 1844, Joseph and the saints were in Nauvoo, where the temple ordinances, by and large, were developed and other revelations were received. So if you'll try to keep these places and these dates in mind, it will help put into context what we learn about Joseph's revelations. Anyway, let's move on and talk a little bit about terminology. Yes, we often think of science and religion as being at odds, but there are other terms that are perhaps more sophisticated and well-defined for those. One is theology in place of religion, the other natural science in place of just science. So let's take a look at those together just briefly. The word theology in English, when looked up in the dictionary, means the study of religious faith, practice, and experience, especially the study of God and of God's relation to the world. It comes from the Greek, theos and logos, meaning God and word or reasoning. So we're probably going to use theology as much as religion, maybe more in this course, because it is focused on faith and especially the study of God and his relation to the world. It's interesting that one of the important books of LDS theology or doctrine during the 19th century by Parley P. Pratt had these two words in its title: The Key to the Science of Theology. Now, the full text of this is online. Brother Perrigo has put these on Google Drive that you should have access to, and we'll be doing readings from this book and the other books over the course of the weeks. Since we're going to be reading from this book today, I thought it'd be interesting to introduce Parley P. Pratt to you, and along the way, try to fathom, try to understand why he would connect science and theology together in the title of his book. Parley was a contemporary of Joseph Smith, born around the same time. He only lived to be 50 years old because he, like Joseph, was actually martyred. He was a convert just as the church had been organized and was instrumental in moving the church to Kirtland. In fact, it was because Parley introduced the church to Sidney Rigdon in Kirtland that the church essentially moved there. That's a very interesting story all in its own. He was one of the original 12 apostles, a close confidant of Joseph Smith, and when Joseph died, he followed Brigham west when the church divided and some of the saints followed Sidney Rigdon and others. He was a prolific writer of pamphlets, books, and hymns. And his autobiography that you see here is quoted as being possibly the most important Latter-day Saint historical work written in the 19th century. It was published in 1874 after he died, a kind of collection of his reminiscences. Let's talk about the key, this key to the science of technology, of theology. Why science? Well, science had a different kind of usage back in his day than it does today. It comes, of course, originally from the Latin scientia, which means knowledge. And it was a general term back in Parley's day for systematic knowledge. So you could have the science of pretty much anything as long as the knowledge was systematic, I guess. In those days, the people we call scientists now were called natural philosophers. And what they did was called natural philosophy. And I kind of like that name because in the Greek, the origin of the word philosophy comes from philo, love, and sophos, wisdom. So a natural philosopher, that is what we call a scientist nowadays, is really a lover of wisdom about nature. And that kind of sums up the way I feel about nature. That's kind of my professional life in a nutshell, I guess. So what about the term scientist, just as an interesting sideline here? The term scientist was actually invented around Joseph Smith's time at Cambridge University. Before that time, the word wasn't used. So a scientist was someone who practiced science. See how language tends to evolve. Well, anyway, that's a little bit of a sideline. The key to the science of theology. You had a chance to read the very first portion of Parley's book before coming here today. I hope you did. And I hope over the course of the next few weeks that when you have something to read ahead of time, that you'll do that. He talks about how theology is the science of communication between God, angels, spirits, and men, the science by which worlds are organized, and so on. It's interesting, though, that Parley sees theology, that is the study of God and the relationship of God to man and nature, as something that can be collected together in an organized fashion, as a science. How about natural science and theology? Natural science, of course, is a narrower part of all that could be called science. We call what we call what they called natural science back then. We just call it science now. When people hear the word science now, we tend to think of things like chemistry, physics, biology, and so on. But however you want to use the words, natural science and theology do have a common objective, and that is to understand the truth about the world. And by the world, what do we mean? Do we mean just the earth? No, traditionally, the word world was used to mean what we now call the cosmos, or the universe. So natural science and theology have this common purpose to find truth. And the point of this slide is to illustrate the fact that there can only be one, that we can't have two competing and non-consistent truths. So science and technology and theology should work together hand in hand in helping us come to an understanding of the world, the universe, and that includes the universe in which we find all of the elements of theology as well. So what is the source of the truth then that natural science and theology are both seeking? Well, Brigham Young, who was the prophet who succeeded Joseph Smith, put it clearly that God has revealed all the truth that is now in the possession of the world. So God is the source of the truth, right? And he goes on to say, whether it be scientific or religious, the whole world is under obligation to him for what they know and enjoy. They are indebted to him, and I suppose we could say we are indebted to him for it all. That's found in the Journal of Discourses, which is a set of books that contains an account of the conference talks of the 19th century, essentially. It's kind of like the conference report from back then. Now we find it in the journals of the church, but back then it was in what is called the Journal of Discourses. And this teaching brings to mind a scripture in Ephesians. You can see it here, that in the dispensation of the fullness of times, he might gather together in one all things in Christ, both which are in heaven and which are on earth, even in him. Now, you're probably going to learn that I love to dig into the meaning of words. And the word dispensation is an interesting word because in LDS culture, we typically use the word dispensation to mean a certain length of time. But as a matter of fact, if you look the word up in the dictionary, that's not in there. The word dispensation really means to deliver or to dispense something, like dispensing water into a glass. So the dispensation of the fullness of times is really the Lord's gift of two things to his children on the earth. And this has happened over and over again over time. There have been dispensations of priesthood and truth and light at Adam's time and Noah's time and Abraham's time and so on. These dispensations are the delivery of priesthood and truth and light to God's children through prophets. That's what dispensation really means. So how about the dispensation of the fullness of times? We're living in it. And I think we all recognize that science during this time has taken great strides forward, but so has religion in the sense of latter-day revelation. An example in science. I'm a chemist, so what comes to my mind, of course, is atoms. When you think about it, our understanding of the fact that atoms exist and how they work is at the heart and the root of all the things that we enjoy in life these days. All the conveniences and the fancy things that we have in our homes are a result of the Lord's offering to us the understanding of the way materials are put together and how to manipulate them. And I'm not at all shy about giving the Lord the credit for this, even though most scientists perhaps would not. I look at it that way myself. And in fact, I went into the lab and we did some experiments with the illustrate. Let's go in the lab and just do a fun experiment together. The atomic model has been very successful at explaining the phenomena that we observe in nature. I'd like to illustrate one for you right now. This is called the luminol demonstration. I'm going to mix these two chemicals, or as chemists are famous for doing. And you'll observe when we do, let's have the lights out, that we see this beautiful blue glow. Now, we're used to seeing objects in nature give off light when they get hot, but what's interesting about this chemical reaction, as I touch the flask, I can feel that it's cool, and that's quite unusual, isn't it? Well, I thought you would probably love to just admire the chemistry that's going on here. Don't try to memorize it, don't even try to understand it, just enjoy it. We have chemical species. These chemical species are reacting with one another to produce, finally, a chemical species that is at an unstable state, and so it gives off light. And that's all I wanted to illustrate. I wanted to illustrate for you how understanding how atoms work is at the heart of how chemists are able to do all the amazing things that chemists do. It's important to understand that atomic theory was not known in Joseph Smith's day. And let's see, remember that day we're talking about is between 1820 and 1844. It was not until later that atoms were really understood to any great degree. And we're going to talk about that in a future lecture. But the fact that we do know how atoms work has not only enhanced our understanding, it has enhanced our quality of life. How about an example in theology? Perfect example is this beautiful temple in Rome. the temple has been a great step forward for the children of our Heavenly Father here on the earth for a whole bunch of reasons, a few of which, just 3 of which, I've mentioned here in this list. Baptisms and work for the dead, sealing of families together, and the covenants that we make there that make it possible for us to advance. Temple ordinances, again, of course, were not understood before Joseph Smith's day. And it was in the Kirtland Temple, let's think, that was back in 1836, and in Nauvoo, where the temple ordinances were first revealed in the upper level of Joseph Smith's red brick store here. Well, these ordinances not only enhance our understanding, not necessarily of the natural world, although to some degree, I would say, but they certainly help us understand our Heavenly Father and His plan for us. But they also greatly enhance our quality of life, giving us meaning in our lives. And we'll be talking about meaning as obtained through religious understanding later in the course in great detail. So, back to our original question. Do science and theology always agree? And when my wife, Betty, Sister Lamb, saw me making this slide, she said, you know what, you should change that word always to ever. Yes, they do sometimes agree. And what's amazing is that in the latter days, through the revelations of Joseph Smith, we find agreements that never existed before. And areas where apparent conflicts existed have now been resolved thanks to him. This gives us confidence that for other areas where there has not yet been resolution, we can have hope that they will be resolved one day. And we'll be talking about that more in future lectures. The apparent conflict and the difference made by Joseph Smith's revelations can only be understood if we can compare how human beings, how we people here on earth understood before Joseph Smith's time, and compare that to how we understood after his time. It, of course, is a principle of understanding that's taught in the scriptures. Contrasts help us understand. For example, in Moses 6:55, the Lord teaches us that we have to be able to taste the bitter before we can prize the good. And of course, that lesson is also taught in the Book of Mormon in various sections. So for the remainder of the time in this first lecture, I'd like to introduce to you the first conflict, the first apparent conflict between natural science and theology, which we will find in the end that Joseph Smith resolved. I guess it's better to say that the Lord resolved through his revelations to and through Joseph Smith. And this first conflict has to do with the nature of the universe, what used to be called the world, or what we sometimes now call the cosmos. In today's lesson, we're going to develop the conflict. And next time, we'll see how the conflict is resolved through new revelations in both natural science and LDS theology. So, in order to understand how this happened, we're going to have to learn a little history, or remind ourselves of some history that we already know. What's the relationship, or what was the relationship between science and religion before Joseph Smith's time? We're going to start with the Greeks, go right up to the time of Joseph Smith. And along the way, we'll find that there are some important figures in the history that lived and worked right here in Italy. Let's start with the Greeks. I think we understand through modern prophetic teachings that the Lord taught his children about the natural world, even from the time of Adam. But our historical records about science in particular really go back only to the Greeks. The Greeks may well have learned from the Egyptians and the Mesopotamians, and they in turn may have learned from Abraham, who in turn learned from the other patriarchs. But we'll go back in the historical record to the Greeks. In about 430 BC, there was a Greek philosopher, natural philosopher, whose name was Democritus. He came from Abdera up here and did much of his work in this part of what then was Greece. We often think that Greece is this, and today it is this country right here. But back in those days, the Greek civilization included the western part of what we now call Turkey. And there were natural philosophers in this area, Samos and Miletus, among them Democritus, who taught some very interesting and novel things. They taught that the world was made up of atoms. And that word came from the Greek atom, meaning not splittable. He taught, Democritus, that there were many worlds with beginnings and endings, and many stars in the universe. That the universe was made up of the same material that the earth is made of. He taught that there was just one earth. I'm sorry. He taught that there was more than just one earth, unlike his contemporaries who believed that there was just one. So this approach that Democritus and a few other natural philosophers of his day really reflected a kind of attitude that the universe was mechanical, made up of atoms, and that all that happened in the universe resulted from rearrangements and movements of atoms, and that there was no need for a God to explain all the phenomena that we see. So their teachings caused what I guess we might say, excuse me, is the first known conflict between science and religion. Of course, in the day, the general thinking among Greeks was that there were gods and spirits whose influence was behind every event that occurred on earth and in the heavens. So how did this conflict between religion and science end back in those days? Well, it ended in the death, the rapid discrediting of this particular kind of science, which was replaced by a science that was taught by a different school of philosophers, among them Aristotle. And he is singled out because he became probably the most prominent teacher of this alternative view of the world. Let me remind you what his view of the world was. He placed the earth at the center of the universe, and around the earth were the planets, which included the moon and the sun, and what we today call the planets. And each of these planets moved in perfect circles around the earth. Beyond the planets, which, by the way, were associated with different gods in the Greek set of gods, beyond the planets were the stars. And this is the interesting part about Aristotle's philosophy and how he described the universe. Why was the earth at the center? Was it because it was the most important and wonderful place? No, just the opposite. He said that the earth was at the center because that's where all the bad stuff of the universe, the heavy stuff of the universe, fell. it naturally fell to the center of the universe, forming the Earth. So the Earth was kind of like the cosmic junkyard. It was made up of four elements: air, fire, earth, and water. And there were few regular patterns in the way that the materials of the Earth operated. This is very different from what was true in the heavens. The heavens were made of a completely different material called the quintessence, or the fifth element. The materials in the Earth, air, fire, earth, and water, all fell to the center of the universe to form the Earth because that was their natural motion. The natural motion of all these four things was to fall down, move down towards the center of the Earth. But the heavens, made of quintessence, the quintessence, its natural motion was to go around and around. Why? Simply because that's its nature. That's just what it did, for no reason other than the fact that that's what its nature was. Moved in perfect circles. This was the realm or the home of the gods. And the important thing that I want you to remember is that there were different rules for the materials on earth, water, air, and fire, and the materials in the heavens. Materials on earth fell down. Materials in the heavens went around and around. This model of the universe lasted in the schools and was taught for 1,800 years and became accepted as unassailable or unquestionable. It was adopted and reinforced in about 1250 AD with the writings of Thomas Aquinas, Tommaso d'Aquino, who lived here in. And his objective was to harmonize Aristotelian philosophy, including natural philosophy, with Christian doctrine. And in fact, there became a strong association between Aristotelian philosophy and Christian doctrine because of his writings. His writings were taught in the schools for hundreds of years. And you've got to remember that the schools for the Middle Ages were pretty much all religious schools. And the teachers of those schools were clerics. Again, the Aristotelian model of the world was taught and became to be accepted virtually as a kind of norm among the Christian teachers, not only Catholic, but Protestant as well. Because the model that Aristotle offered, among other things, gave a place for God and angels to live. Rather than ancient Greek gods, we find courses of angels living in this quintessence, going around and around the earth. And of course, the earth to Aristotle was a junkyard, which fits with traditional Christian belief that of the fall and the corrupt nature of materials. So again, in large part, or in some part at least, due to the writings of Thomas Aquinas, who did a wonderful job and did such a great job that he was given the name Dr. Angelicus, a name that I guess any scientist would love to have, Dr. Angelicus. But this Aristotelian model lasted for 1,800 years. That's a long, long time for it to become ingrained in the culture. And so even after Thomas Aquinas, it was taught in the schools for another 300 years. Of course, we know the story of the Renaissance and the development of the more modern sun-centered model of the solar system. Started with this man whose name is not pronounceable by me, but we call him Copernicus. And he was educated in Bologna and Padua and taught a sun-centered world. Around the same time, in the late 1500s, in Napoli, Giordano Bruno was teaching the same thing and went even further. He taught that the universe was made up of atoms, that there are many worlds with beginnings and endings and many stars. He did not believe in Aristotle and taught that Aristotle's teachings were false. And for that and for other reasons like denying the authority of the Pope and the divinity of Christ, he was burned at the stake on the Campo dei Fiori here in Rome. Well, you'll remember that another important scientist in this story is Galileo, who worked in Padua and Pisa. He used the newly discovered telescope to find that there were little planets, which we call moons, around Jupiter, and so on, that proved once and for all for most people that the sun-centered model of the universe was actually true. But this caused a great consternation among the teachers of the schools, and as a result, Galileo was put in prison for the last 11 years of his life by the Inquisition. And this represents, I think, in terms of our study of the conflicts between religion and science, probably one of the highlights of this conflict that has now developed between the traditional Aristotelian model of the world and the modern model that Galileo was promoting. So the conflict is now heating up, the conflict about the structure of the cosmos, the structure of the world. Isaac Newton comes along, and he is famous for inventing for creating our current model of gravity, which explained why it was that the moon goes around the Earth and the other planets go around the sun. And I have a little video here that I'd like to share with you, we'll go ahead and share it. I think we have time.
While necessarily interested in falling bodies, Newton sought to explain something else about gravity. If apples fall to the earth, why doesn't the moon? Could it be that the same law applies? Newton's argument was to imagine someone casting a projectile horizontally, firing a cannon, for example, from somewhere high above the Earth's surface. From Galileo's discovery, Newton already knew that a body dropped from 16 feet above the Earth's surface reaches the ground in 1 second. The distance a cannonball travels depends on its velocity. If the projectile leaves the barrel at 30 feet per second, it travels 30 feet before it hits the ground 1 second later. But Newton realized that if the projectile were fired fast enough, it would take more than 1 second to reach the ground. The Earth would curve away before the cannonball reached it. In fact, he could imagine a cannonball moving so fast it would never strike the ground. It would just keep falling forever, while the Earth forever curved away beneath it. In other words, it would be in orbit.
So Newton sees an apple fall to the ground and ascribes the process to gravity. But then he sees the moon.
Zero G, while necessarily.
Then he sees the moon going around the Earth, and he decides that maybe the moon is also falling to the Earth, but moving sideways so fast that the Earth moves out from under it and it goes into orbit. Now that's how we usually think of Newton's revolutionary ideas. But in fact, there's an even more important contribution that Newton made. And that is that the law of gravity is universal. as opposed to what? As opposed to Aristotle's idea that the moon was composed of a different material than the Earth and didn't go around because of gravity, but went around because the quintessence moved that way just by itself, just because that's its nature. And so, from the point of view of our story here, Newton's most important contribution is not so much gravity, but the fact that he says that the moon, the planets, and the stars are all operating under the same set of laws as the materials here on Earth. And that undermines the idea that upon which Aristotle's model of the universe is based. Aristotle's model was based on the idea that there are different laws of nature in the heavens than on Earth. And Newton pulls the rug out from under that idea, saying that the same laws apply in the heavens as on the Earth. And for this reason, this caused a lot of trouble for those who had used the Aristotelian model to underscore the validity of Christian doctrine. If the universe can be explained in the same mechanical ways as cannonballs here on Earth, then is there a need for God? And another important question, if the moon and the planets and the stars are all made of the same materials as on the Earth, where is God? Where are the heavens? Where are the angels? It used to be that if you asked someone, where is heaven? They would simply point up, because up was where the quintessence was and where the angels and the gods were. Now, where is God? So this is where we stand pretty much at the time of Joseph Smith. In the late 1700s, there is a crisis of faith because of the undermining of the Aristotelian model. And better telescopes are showing us that there is a host of stars out there. Now, today we think of many galaxies, but the idea of at least one galaxy had been postulated by some astronomers in Joseph Smith's day. They claimed that there was a large but a limited number of stars, that that there were planets in our system, our solar system alone, elsewhere. But you can see that this revolution in science has created a crisis in faith and in religion. At the same time, of course, Joseph Smith is ushering in a new dispensation, a new dispensing of truth through revelation that we're going to talk about next time that will resolve this problem. Some of the revelations of Joseph Smith do, in fact, refer to the processes that are usually ascribed to natural philosophy. But there was a revolution in theology that Joseph Smith brought about that is going to help us resolve this problem. I'm going to skip over the next couple of slides and present them to you next time. I just want to underscore how important it is that we ascribe to the Lord all the good that has come to us in the latter days, both through revelation and science. And it's emphasized here in Doctrine and Covenants 121. where Joseph is writing from Liberty Jail to the saints in what will become Nauvoo. What power, the Lord says, shall stay the heavens? As well might man stretch forth his puny arm to stop the Missouri River in its decreed course, or to turn it upstream as to hinder the Almighty from pouring down knowledge from heaven upon the heads of the Latter-day Saints. This idea is underscored with a comment from Brigham Young. Every discovery in science and art that is really true and useful to mankind has been given by direct revelation from God, though but few acknowledge it. It has been given with a view to prepare the way for the ultimate triumph of truth and the redemption of the earth from the power of sin and Satan. Notice that Brigham is telling us that everything we learn that is true in both religion and science has its source in our Heavenly Father. So let me invite you to stay tuned for next time, because next time we're going to see that God reveals greater truths through both natural science and prophetic revelation that will solve this conundrum. The apparent conflict between science and religion is going to melt away. So let me invite you to rejoin us next time, and we'll talk about this further. Thanks for being with us tonight.
Well, thank you, Anciano Lamb. It was very interesting and wonderful. Thank you also for speaking and talking slowly so that we could all follow you along. It was very helpful. Now, I think we have about 5 minutes or 10, 5-6 minutes if anybody wants to ask a question. I would prefer if you use the option to raise your hand so I can see if you have a question. I can give you the word rather than everybody kind of jumping in. If you know how to do the question, otherwise you can write in the chat, I have a question, and if you don't know how to use the raise hand option. Again, for those that connected during the lesson, if you can write your name in the chat, that would be helpful for me as well. So if you have any questions, we can take them now, or we can close the meeting. I don't think we had an opening prayer. We should do one at the end, probably after. That was my bad. I was too excited to get started. So do you have any questions? You can write them in Italian if you want in the chat, and I will translate it. Try to. And as you think that, I'm gonna start asking also if Sorella Romano can do the closing prayer afterwards. Okay, I think we're good. We are going to maybe see if there are any questions in the chat or in the WhatsApp group. So I'm going to stop the recording.